Okay. Welcome to the end of chapter 1. Just so that people know, when I'm putting this on the internet, we don't start with chapter 1. I know this is November. We started with chapter 5, did 5, 6, 7. Now we're doing 1, 2, 3, 4. So this is the end of 1. And I want to talk about the end of chapter 1, and that is corrosion and combustion. I want to try to get through this before the end. I've got like 20 minutes. All right? Now, there's different kinds of corrosion. When everybody thinks of corrosion, you think of this. You think of rust. But rust is like iron 3 oxide. I'll tell you a little story about iron 3 oxide in a minute. But there's also tarnish, which is the formation of, I got it right here in the web, just to make sure I got the equation right. Silver 1 sulfide, right? Solid. Okay, that's what tarnish is. And the equation is 2Ag solid plus H2S gas yields Ag2S solid plus hydrogen gas. Well, that marks about that, isn't it? Okay? That's what the equation is for rust. Now, if you look at this, this is, you can hardly read that. This is hydrogen sulfide, rotten egg smell, right? Rotten egg smell. And this was in, this is all over the place. This is in the air naturally. There's always something around. It's actually from pollution, the hydrogen sulfide. And in England, in the late 1800s, you had a lot of coal being used. And coal has impurities in it. And the impurities it has in is sulfur and sulfur-based compounds. And you produce tons and tons and tons of this rotten egg smell. You produce this. And then when you get this fog, this horrible fog in Britain, you get this acid rain. And it just corrodes everything. I mean, it just makes a complete mess of statues, of marble statues. It makes a complete mess of everything. And the tarnish, you get these workers, polishing the silverware for the gentry, for the upper class. And I don't really feel sorry for the upper class and their silver, but I felt really bad for the workers. Nearly got paid slave wages to help polish the silver, and it's just horrific. But it doesn't hurt the silver underneath. You get that? This tarnish actually protects the silver. It protects it. What happens is this. The silver sulfide forms this impenetrable skin over the silver that nothing can get in. As opposed to, does anybody have the equation for the formation of rust yet? Nobody? You have it. You have the equation. You have it on your phone. I just don't remember it offhand. You have it. Can I see it? Excuse me for a second. Okay, this is not what I'm looking for. Yeah. Yeah, could you look up the chemical equation? Look up chemical reaction for rust. Anyway, what happens is, when this forms on the rust, it acts like a sponge. and it soaks up water, which catalyzes the reaction for rust even more. So when you form rust, can I erase some of this stuff? Where's my toilet roll? There it is. When you form, can I erase this? Tarnish, impenetrable skin over the silver acts as a protector. Okay? It's black though, so the silver doesn't look nice. Yes, tarnish is black. What they'll do now for silver is put a lacquer over it so it stays nice and shiny. But it really is black. Gold doesn't tarnish like silver does, nor does platinum, so it's more precious. But when the silver's polished, it looks great. Okay, so here's the reaction. And so it's not turning with my. How do I turn this? It's not turning, dude. How do I get this so I can read it? Here. Get this so I can read it. Okay, so the rust, though, will literally consume it. When these big ships, what's the town where they cut the ships apart? There was an article in National Geographic where it's one of the most dangerous jobs in the world. And it's in Bangladesh. And what they do is they take these old rusting ships that are big as giant buildings, and they take them apart and sell the scrap metal. It's in Chittagong, is that right? Chittagong? Yeah, it's in Chittagong, in southeastern Bangladesh. And anyway, these ships are a rusting mess. And if you literally left the ships in one place, in a rainy area, they would just disintegrate and simply form. That's it? Yeah, but that's not the only reaction. I knew that. I knew this. It's a much more complicated reaction. Could you look at the complete chemical reaction? That's just the sum. This is just saying that iron plus oxygen yields iron 3 oxide. Let me tell you a little story about iron. You have two types of iron. You have iron 2 and iron 3. Blood. Oxygenated blood. Oxygenated blood. When you have this heme group, and I mentioned it before, okay? You have this heme group. You have these four are attached to the globin, in hemoglobin, in the red blood cell. And then this one attaches attaches oxygen. Okay? When that oxygen is attached, it's locked in the +3 state. Right? It's locked in the +3 state. It's nice, rich, red blood. Right? When it's locked in, so this is red. This is an ugly, dark brown, little reddish tint, but mainly very, very dark brown. It's really kind of ugly. When you make, although this is a Muslim society, you don't eat pork, but in Western societies, Christian and Jewish and Hindu, well, maybe not Hindu, but I don't know what they eat. They eat a lot of beef, but they don't eat beef, I'm sorry. I'm being very politically incorrect, I guess, but I don't mean to. I apologize to everybody if I am. But anyway, you get prepared meats, right? You get pork products, meat, etc. And you get salami, bologna, bacon. You've heard of these things. You haven't eaten them, but you've heard of them. And they're red, right? They're red. You go to the store and you can see them. In Western societies, you go to the store and they're red, right? And people like them and they look good, and they look delicious, and they look fresh. Well, the reason they're red is because we put in them this. We put in sodium nitrite. We inject that into the beef. The sodium nitrite locks the iron 3, locks the iron into the iron 3 state. So we put sodium nitrate into the meat, and it locks the iron into the +3 state. Now, this is the deal. When you take bacon, let's say, bacon which contains sodium nitrates, right? And you cook it at high temperature, like on the stove, you produce something called nitrosamines. These are carcinogenic. Well, what they did in Britain, in the UK, is they took the nitrites off the market, and the meat was dark brown. It was not very appetizing. Well, the public wouldn't buy them. They went absolutely nuts. And the industry, the prepared meat industry, put the nitrites back, even though they're carcinogenic. Microwave bacon is safer, although you can eat the beef one. They have beef bacon. How do you eat beef bacon? Raise your hand. Anybody? Yeah, you eat beef bacon. So that's safer because it doesn't cook at high temperature. It boils water essentially, and you don't produce the nitrosamines. So let's just review what I said. You have rust, correct? You have rust, which is very sponge-like. It absorbs water with the oxygen in it, and it catalyzes the reaction for the formation of more rust. So you can literally take a giant iron ship and degrade it into nothing, correct? Where other corrosion, like copper corrosion, aluminum corrosion, you find the example of aluminum corrosion? Aluminum corrosion, silver corrosion will protect the metal. Iron doesn't protect. And then you have the case of two different types of iron. Iron 3, which is blood red, okay, and then iron 2, which is a disgusting brown. The iron rust is +3. And so, in order for prepared meats to maintain its bright red color, they put in nitrites, sodium nitrite, and they inject that into the meat. Sodium nitrate, maybe, probably, but it's sodium nitrate. And it makes it red. They take the nitrites out, and it's an ugly brown. It's disgusting. Okay? Got it? Okay. So that is a little talk about corrosion. And it's similar to what is in the book. Okay? Anybody have anything to offer relative to other types of corrosion? Anybody? Nabila, did you find the reaction? You didn't look. That's okay. Understood. Did you guys find the reaction? Bragma? You find the reaction? Anybody? Nobody?
Sir, I found the reaction.
All right, we got something here. We got something. It's 6 steps. All right. Well, I'm not going to read it all. It's really kind of complicated. I'll give you the final thing. It says 4 copper plus oxygen, and then it's going to finally produce copper sulfate. Very confusing compound. But anyway, the point is that it's going to make it's very complicated. But it forms this kind of like this, what is the book called? The patina? The patina, and it protects it, like the Statue of Liberty in New York Harbor. Anybody ever see the Statue of Liberty in New York Harbor, or pictures of it? It's a beautiful, beautiful, beautiful green. And really, the color of copper is kind of like an orange, brown, shiny color. You know what a copper looks like? What is it?
Shiny brown.
Shiny brown?
No, it's not shiny. It's
Well, no, you can shine it. You can shine it so it looks really good. You can. And it's kind of gold-like, but more brownish than gold. The copper is a beautiful color. You know what copper wire looks like? That looks nice, yeah. That doesn't look corroded. But when it forms that coat of corrosion, it is a beautiful green color. Yeah? Okay, do we have the aluminum? No? Aluminum corrosion is is aluminum oxide. That's what the coat of aluminum is. And again, you have it on your pots and pans at home. Okay, if you take that off, aluminum is this shiny, beautiful, silvery color. Not quite as hardy looking as real silver, but it's still very shiny and very beautiful. Good shiny aluminum can literally be a nice replacement for silver. And the thing about aluminum is it's not very dense. You know, I don't know what the density of silver is. Water is 1. Rock can vary between 2 and 4 grams per cubic centimeter. So rock could be light. It could also be a little bit dense, not much. Iron is like 8-ish, yeah, as an average. I think mercury is 13.6. These are all in grams per cubic centimeter. So water is 1, so mercury is 13 times that. Gold is like 19. Platinum is like 20. I think there's one that's 21. Yeah. These are densities. These are densities. And aluminum is 2.7. So it's a very light metal. Very, very light. I'd like to know what titanium is. Can someone look up the density of titanium, please? Now remember, these are all grams per cubic centimeter. That's water is 1, so everything is relative to water, okay?
4.5 grams per centimeter.
Titanium is what?
4.506 grams.
4.5. So titanium is
4.506.
4.5. Okay. 4.56.
4.506.
4.51. Okay. Okay. So what's platinum? Will somebody look up the density of platinum? What is it?
Is it 30?
I don't know. I'm asking you. I think it's around 20. Gold, I think, is 19.
81.4.
What is it?
81.4.
21.4 is platinum. Look at the density of, this would be interesting. Look up the density of radon gas. Radon gas. This has to do with the chapter because it's physical properties, but I know air is about 1.3 times 10 to the negative fifth. That's about air, right? Carbon dioxide is 1.8, so it's more dense than air. What's radon? Anybody have it?
9.73 kg per centimeter.
What is it? Let me see. All right, so it's 9.73. Radon is 9.73. I think this is third, actually. I think that's third. It's about 9 times the density of air. Yeah, so it's pretty dense. If you put radon in a balloon and you put air in a balloon, this one would slowly drop, mainly because of the mass of the balloon. This one, radon would drop like a rock. Yeah. Oh, here. All right. So the last thing I want to talk about, I don't know if I have time. What time is it? Are we done? Are we done? Are we done? All right, what I'll do is I'll cheat a little bit. We have math twice today. I don't plan on doing any more new material. I plan on reviewing old material.
We have English.
Yeah, we have math twice.
Yeah, we have English.
You have English now? Okay, I'll let you go. But I'll cheat a little bit and finish up in math, check homework, give review quizzes, do some word problems, give you some work to do that'll be graded. And it's going to be kind of a weird day, okay? You guys all set? So that is the end of corrosion, yeah? And there's also, let me just finish with this. The Titanic is disappearing. 1912, April-ish, hit an iceberg. You know what I'm talking about? Like that? Yeah? Okay.
It's rusty.
What is it?
Because of its rusty.
Because, no, it's not rusting. Yes, it's rusting. But that's not really why. Ships that are in fresh water, like not salt water, that are really deep, they don't rust as much. Yeah? It's the salt water where they rust. But that's being eaten by a bacteria. There's a bacteria that lives very deep in the ocean that eats rust. What are you having for lunch today? Tell me, quickly. What are you having for lunch today? What are you having for lunch today? Quickly. You heard what I said. What are you having for lunch today? Anybody? What are you having? Porota? Porota. I don't know what that is. Porota? Is that like a horrible word I just said on the air?
That is bread.
Porota is bread?
Pita bread.
So why don't you say I'm having bread?
It's just like pita bread.
Pita bread, okay, porota, okay. Well, the bacteria eats iron for lunch, and breakfast, and dinner, and snacks in between, and before it goes to sleep at night. That's all it eats. It eats iron. So the ship is being digested by bacteria. True story. You heard it here first. Have a great day.
Oh my God.
Goodbye.